Hi there, it's Ben at Fidelity Designs Limited here. Haven't done a video for a while, but wanted to share a couple of products with you. These are a couple of items I've made for a customer. It's a subplatter and bearing and a platter. And it's similar to the other products I've been making, but it's taking things a bit further, so it's an evolution of the products. So if we have a look at the subplatter first. I think this is going to be used in a custom Rega type turntable, so it's based on the RP6 or RP10. So this subplatter and bearing, it could be used in any Rega turntable that uses an 18mm type brass sleeve bearing. It's for the RP6, so RP6 subplatter, it's a bit deeper than the standard Rega ones. It's about 6mm deeper, so approximately 18mm in depth, and fitting with the low centre of gravity theme, because when designing turntable bearings this is where it's all about. So it's all keeping the centre of gravity low and the point of rotation high, which an inverted bearing would be the ultimate, but inverted bearings have engineering difficulties, you have problems with lubrication, so not really suitable for production turntables everyday use, although it can be done, and it has been done in turntables in the past. So if we have a look at the subplatter, it's dished on the underside, so the bearing sleeve, just show you, I'll just slide it on, it sort of fits on the inside of the subplatter to keep the centre of gravity low. So you can just see the top of the sleeve protrudes from the plinth, and subplatter fits over it. If you look at the sleeve itself, similar to the other designs, a wider shoulder on the top to give a bit more support, and using PEEK for the two internal liners now. So the liner at the top and the bottom using PEEK material now, which is unusual material. It's an engineering plastic. It almost feels like a ceramic type material. It isn't, it's plastic, but it's very hard, stiff material. Depending on the application, there are some issues with machining it. Its properties are quite unusual for a plastic. Like I say, it's more like a ceramic, so very hard wearing. Excellent material for making liners for bearings. It's also got quite a high lubricity, so its coefficient of friction is very low. You know, similar to Delrin or Acetal, maybe slightly better. So excellent material there. So that's an improvement in itself. Now if we look at the platter, this is an acetal platter, so polyoxymethylene, acetal, similar to Delrin. Delrin branded material, slightly different molecular structure. It's a copolymer. Sorry, the Delrin is a homopolymer instead of a copolymer, which is what you get with acetal. But they're both polyoxymethylene, so very similar materials. Anyway, this platter's been made out of acetal, which is fine for the purpose that it's used for. This platter's going to use the deeper subplatter, so the 18mm deep subplatter. So I'm just trying to move it into the shot of the camera. If you can see, it's got a really deep pocket machined on the inside. So let's put the subplatter in. Subplatter fits in there, and then put the bearing sleeve in there. So if you look at it, it's really recessed into the platter as much as is practically possible, and you've got the bearing sitting inside the subplatter as well. So if you look at it there, everything is centre of gravity, it's as low as possible. trying to balance it. Okay. Spin it up. So you can hardly see it moving. It is moving, but everything's completely balanced, so it's, you know, it stays completely stationary. So I mean, I'm messing my words up a bit here, but I hope you get the point of what I'm trying to get across. And this is where we're at now with the platters and subplatters. Obviously, this is a higher end version, but takes the other stuff I've been doing and takes it to its logical conclusion, really. Thank you very much. Hopefully more videos soon. So speak to you soon.